Okay, take two on this lesson. So we're going to be talking about residuals today. And you may have heard, the term residual before. It's basically means like a leftover amount. So residuals. So basically what happens is our line of best fit, unless we have a perfect correlation of 1, is not going to pass through all the points in the scatter plot. So then if it doesn't, which is almost all the time, we're going to have what's called a residual. And a residual is just the difference between the actual value of y and the value of y that is predicted by the regression line. And usually we're going to be using the least squares regression line, which is LSRL, because that's a very long term. All right, our actual formula for a residual equals actual y minus predicted y, which is equal to y minus y hat. Again, for some reason, I can't make on this particular program a actual y hat, but you know the deal by now. All right, so let's look at some data here. And I think I have this in there from my last one. I'm going to delete that so I can show you how to do it later. So I put in, we're basically finding the relationship between a student's GPA and their ACT score. So here's our data right here. If someone with a GPA of 3 has an ACT score of 19, et cetera, you get it. All right, so we put this data in. So this is our actual data. If we want to find our residual, let's say the residual at a GPA of 3.5. So if I want to find the residual at 3.5, what I'm going to do is I'm going to take the actual ACT score, all right, at 3.5, which is 27. So it's y minus y hat, which is our predicted y. So that's 3.5 minus, and then we have to figure out what the predicted value is. So we need the predicted value. I got to bring up my calculator. To get our predicted value, we need to find our actual equation. So we're going to stat. We're going to over to calc. We go to our linear regression. And we see that our slope is 7.75 and our y-intercept's negative 0.68. And we see that also there's a correlation of 0.69. All right. If we want to see this scatter plot, we can do so. And I'm just going to put list 2 as my y list. Let's get our window set up. All right, so our grades are going from 0 to 4. That's our GPA. Our ACT scores, let's say, go up to about 50. All right, I don't really like that window, so let's say we'll start at 10 and go to 40 instead. Still not loving that. Let's look again at our data. Our lowest is 19. Our highest is 31. That actually seems okay, I guess. 35. Maybe we'll get a better reading there. Okay, still not great. So what this actually means, this data here, is that for every GPA point you go up, if you go up a full GPA point, your ACT score is going to go up by 7.75. And what this y-intercept b means here is if I had a 0 GPA, I would get a negative 0.68 ACT score. Now, you can't get a negative ACT score, so basically we would not want to use the equation that far. That would be what's called extrapolation, where we go outside of our range. So we want to stick around our 3 to 4 range here. All right, so let's put this in there. We have it. And it's not showing our graph, which means there's some sort of a problem. And it's our window. Go from 0 to 40 again. Oh, I'm hiding it. That's why. Sorry for that. And here we get our least squares regression line. And we can see here that it looks like a pretty good line. It should be. It's the best possible line. All right, now let's go back to calculating our residual. All right, so what we're going to do is I want to first find y hat, which is our predicted y. And that's just plugging in 3.5, which is the GPA we're trying to find. All right, and when I plug that in, 7.75 times 3.5 is equal to 27.125 minus 0.68. That's going to be 26.445. So that's our y hat. So to find my residual, it's just y minus y hat. Y is 3.5. Y is 27. Minus 26.445. And that means our residual is 0.555. What that means is that the point at that 0.55 is about half a point above the line. And I'm guessing that's going to be this point right here. All right, at 3.5, we can trace to check. And it is 3.527. All right, so that means it's above what we would predict by about half a point on the ACT. All right, so that's what our residual and how to find it. All right, we can use the calculator to get our residuals. And it's pretty neat. All we need to do is highlight this L3. And what I'm going to do is I'm going to put, I hit this vars key. Nope, sorry, it's second stat. Hit this list key, and then I go down to resid. And this is going to give me the residuals for each of my points. All right, pretty crazy. So a negative residual means it's below the line, a positive residual means it's above the line, and then we go from there. All right, we also have something called a residual plot. And all a residual plot is, it's just a new scatter plot of the residuals with the same x values on our horizontal axis. All right, so it's basically going to use the same scale as we had before. And I can make a residual plot again on the calculator. All I need to do is, instead of y list here, I'm going to change this, again, second step, and I'm going to put my y value as a residual. Now, if we look again at those residuals, we can see that they're going from -3 and change to about 5.6 here. All right, so that's going to influence our scale. We can keep the x scale exactly the same. The y scale, let's go from -6 to +6. We'll count by ones. And I don't want that line on there. And this is our residual plot. All right, if I get rid of some of those values, we can center it a little bit better. So here's an example of our residual plot. All right, we have a couple points above and a couple points below. Now, something interesting about the residual plot is we want to look for a pattern in the residuals. And if there is a pattern, if there's no pattern in the residuals, that means our model is appropriate. All right, so it's appropriate. We use the linear model. It's appropriate to use a linear model. And we can clearly see there's no pattern. These points are all over the place. There is a pattern in the residuals. And it's usually going to be a curved pattern. That means we should choose a different model. All right, we're only going to deal with linear regression, but you do have quadratic regression, exponential regression, etc. We're not going to go on to that. That gets a little bit more complicated. All right, so in this case, we did use an appropriate model. All right, we were able to find the residuals, both in person, both by hand and on the calculator. We were able to plot the residuals and find out what that plot meant. All right. This will be due Tuesday. Have a good weekend and a good rest of your day. Sorry for my error in the last video.